So this is for the midterm. To begin with, we're going to download the zipped midterm exam itself. So I like to use the download with the green. So let's go ahead and click on that. And you can see it downloading there. Once it's downloaded, we'll look at it in the folder. And you can see it there. If I select it, I can right click to extract all. Three data sets, the midterm assistant, and then two versions of the notebook. And we'll want to upload do that, hit new here, and I'm just going to take all of these and I'll drop them right there. And once they're uploaded, then I'm going to open up the notebook. So once it loads, you're going to see that you have two problems. Of course, you'll start out by the usual executing the first cell there, and we're going to be using SKlearn, and so I've put this set of imports by themselves and explained them very extensively. SKlearn is really a nice package, and you're going to use it through the rest of this course. You'll need to put your username here. I'm just going to leave it like that for the demonstration. And then you'll have to run, once you've done that, this cell which loads the midterm, the helper things. In particular, it gives you the ability to draw a tree, do an ROC plot, a PRC plot, along with loading some things that you'll be using, a cancer patient and the movie that you're going to be considering. The first problem, we're going to be looking at a very well-known and well-studied and highly utilized data set called the Wisconsin Breast Cancer Set. So we're going to read it in. And what we have here are several characteristics of breast cancer cells. And class 1 is malignant, class 0 is benign, and this data set can be used to diagnose whether or not a cancer patient, in particular you're going to be looking at your cancer patient who doesn't have a class. That's because you're going to use these measurements to try to predict whether or not it's malignant or benign, whether or not they're going to be doing chemotherapy or simply living with a benign breast tumor. You'll be coming back here. You're going to be using a decision tree. You're going to go through, and all this is in SKlearn. So I've been setting you up to use SKlearn. It's a really nice package. So it's got a way of splitting into data sets. So this is the training data set, and then the validation data set. Let's look at the first 7 or so of that. And we create a binary classifier. And then in order to actually get the features, we simply drop the class, and therefore the training.drop class is actually the features, and training.class is the class for a given observation. And we fit the data, or train it, to get our tree. and then we can visualize that. What you're going to see here is a mess. You might want to change the sizes, but the problem here is that this tree is just far too complicated. You can see without the cell labelings, it's a tree, but it's got lots and lots of branchings. So you're going to have to go back up and get to the point where you can get a tree that doesn't change much from one split to another, and that gives you good area under the curve values. So once we've done that, we can do predictions. So here are our predictions. We can create a confusion matrix, so on and so forth. Now you're going to find that the area under the curve, the statistics, the metrics are all really good. This is an excellent data set, widely used. But this tree is just too unstable. If I do another split, I'll get a tree that looks very different than that. What would really be nice is to get a tree that looked more like this, where you can actually track down the tree and do a diagnosis by just tracking down the tree and ending up with the leaves where you can actually get your predictions. The second problem we're going to look at is the recommender system for the group lens data. We'll be using a k-nearest neighbors approach. Again, we're going to have to use sparse data because this is terabyte sized data, or gigabyte sized data at least, if we try to store all the zeros. That's not uncommon. Big data often has a lot of information that just averages to zero or averages to something that's not significant. That's why traditional statistics doesn't work. So we're going to read in the movies here, and that gives us our movies. And then you're going to have a movie. It's the one corresponding to your movie ID, and this is the movie that you're going to be looking at. Now, in this instance, I'm looking at Forrest Gump. Yours will probably be different. The key here is that once we've loaded our ratings data and then converted it into a sparse format, then we can split it again. It splits actually with sparse. SKlearn uses sparse matrices as well as it uses dense matrices. So here's our training and our validation. And here's the question you're going to address. The only movies you can get are popular movies. I've actually set it up that way. So everybody's at least heard about these movies. So can we predict if a user will like the movie? And liking it means they either give it a rating of 4 or 5 out of 5. So class 1 means they rated the movie a 4 or a 5. Class 0 means they rated it lower or didn't rate it at all. So we have to pull out the actual class numbers, and we do that by just looking at whether or not the ratings are higher than 3. And if the ratings are higher than 3, then they like the movie, strictly higher than 3. Otherwise, we put a 0 in for class 0. Same thing with validation. And this just demonstrates cosine similarity, which is what we'll be using for this. Here's our k-nearest neighbors classifier. We're going to use a cosine similarity, a brute force method, which we have to. You can only use a brute force on a sparse matrix. And we're going to see if we can somehow end up with a good prediction. We fit it to the known data. Then we go to our validation data. There's our predictions. The confusion matrix, the receiver operating characteristic, the ROC plot, I'll show you that. It's not really that great. So we want to improve it. And also, this is not a balanced data set. Given any movie, there are many more who haven't seen it or don't like it than there are those who like it. So we're also going to look at the precision recall. The average precision score is actually the area under the precision recall curve. And then you're going to look at, this may be a little bit slow, but the k nearest neighbors classifier is based on a k nearest neighbors graph. And this is actually a pretty good graph. We've talked at length about how nearest neighbor graphs as is aren't great, but this SKlearn is very sophisticated, and so you're going to look at the degree distribution, and then the degree distribution in log-log scale, clustering coefficient, shortest path length, and say why this is actually, once you get the right number of neighbors, it's pretty good. So what you're going to be doing is you're going to increase the neighborhood size until the validation effort begins to falter. So that's what the validation set is there for. You get as connected a network as possible, many neighbors as possible, until your validation scores start going down, and at that point you stop. You'll also see a lot of these items marked with these symbols. You'll need to especially look at those. I will post a rubric for grading over the weekend. I do think you could use LaTeX. You don't have to. You can use Word if you want to, but if you do use LaTeX, I recommend this sharelatex.com. I had a lot of success with it, with everybody from 7th graders up through graduate students. You can learn it on your own. There are YouTube videos. You can have your first paper written in less than an hour. So that's what I recommend. So this will be due on Tuesday at midnight. I'll be addressing it during my office hours. And you can see that what you're really looking at is we've finished the loop. So now we understand what data science is all about. Exploration, pre-processing, splitting, creating a machine learning object, classifier, fitting it to the data, making predictions, assessing the results. After the midterm, where we're going to go is we're going to see what kind of machine learning objects. We've got 4 very powerful and pretty darn cool algorithms that we're going to look at after this midterm.